Okay, so what is PoE? And really the basics of PoE, or power over Ethernet, is really that you've got the integration of power and data on the same cable. So you're pushing DC power over your typical Cat5e, Cat6, Cat6a Ethernet cable, while also having that same data throughput that you would have over just a normal data cable. But now you've got power available too. And so this integration really allows you to reduce the number of cables, power supplies, and other equipment you need for the devices connected at the other end of that cable. And so early on in PoE, there was a lot of lower powered device applications, whether it's VoIP phones, Wi-Fi access points, IP security cameras. And then as PoE grew and progressed over the last 20 plus years, you've gotten more power available and thus higher power devices. And so really once 60 watts per port per cable became available, then LED lighting became a realistic application for PoE. And so then I've really seen that grow, gain traction, gain adoption over the last 6+ years. And really, we really see in the future, really, any DC powered device being able to be powered by PoE, and I'll cover that a little bit more later on in the presentation. So let's go on to the next slide. All right, so some of the benefits of PoE, cost savings. Since PoE cables don't require conduit, they can be ran in the same cable tray right alongside with your typical data cables. So you save a lot of manpower, a lot of labor and such by just pulling those cables, same cable tray, no conduits required there. As I mentioned on the last slide, the integration of power and data on the same cable, plug and play compatibility. The IEEE is the international organization that really sets the standards for PoE. And so they've done a great job of making everything backwards compatible, cross compatible through the different versions of PoE as it's grown and developed throughout the years. Safety is a big feature of PoE. These are class 2 power levels, 55 volts DC, 100 watts or less. So you don't need an electrician to do the installation or to do modifications or anything. It's all low voltage. It's safe. There's a lot of built-in safety features to PoE that make it easy and safe to work with. So no concerns that you would have with the line voltage power levels, and thus that's a big advantage of it. From a control and management standpoint, PoE fits in well with your typical IT network and the management services and such, monitoring and such that's integrated highly with your corporate network. And then from a power availability standpoint, really any place that you have a data jack, an Ethernet port, etc., you can have PoE power available to power a device, whether it's a light, a cash register, etc. So it really makes it easy from that standpoint. So a few acronyms, kind of some glossary items here that you'll hear me mention in some future slides. The PSC is our power sourcing equipment. So that's typically going to be your PoE data switch. So that's going to look a lot like your typical network switch, except that it's injecting that PoE power onto those Ethernet cables. From a PD standpoint, that's really your powered device. That's what's actually getting powered at the other end of that cable, whether it's a VoIP phone, wireless access point, security camera, or in our case, it's our Igor nodes. And so I'll get into some more details on what exactly encompasses an Igor node. End spans, mid spans, those are kind of two different terms for the devices that actually put the PoE power into that Ethernet cable. And then MDF and IDF are really kind of old school telecom terms that kind of continue to get carried forward as far as kind of where your networking equipment and such is. So your MDF is typically another reference to your central data closet, data center within the building, whereas an IDF is more of, you know, a remote closet spread throughout the building. So, so here's kind of a simplified example of some of those components I just mentioned and how they connect. So back in that IDF, MDF room, on the left, you would have a data rack, and typically you would have multiple PoE network switches in there. And so those are your PSEs, you know, end span, mid span, depending on what type of device they are. And then out of that data rack, you have your Ethernet cable, your Cat5e, Cat6, Cat6a cable. Looks like I've got a typo there. Sorry about that. Going out to essentially, in our case, your light fixtures or any of your other PoE powered devices. And so that cable, from a PoE perspective, has the same length limits as typical Ethernet data cable does. 100 meters, roughly 330 feet. And so we've really, on any of the projects we've done, we've never ran into an issue where we couldn't get to a light fixture or to a device within 300 feet of a closet. So that's usually not an issue. But then at the end of that cable, you've got your PD. And so here's an example of an Igor node. The Igor nodes will typically replace what would traditionally be your line voltage LED driver. And so it's got built-in LED driver functionality there for powering and dimming connected light fixtures. But it's got a number of other capabilities, I/O points for picking up sensors and wall switches and such. And so we'll get into that a little bit later on as well. All right, so looking at kind of how PoE standards have progressed over time. As I mentioned earlier, you know, initial standard was really only 15 watts, you know, so your really low power devices. But as it's progressed throughout the years, 2009 and above, you know, you get to 30 watts, and then really Cisco came out with their proprietary standard, I think somewhere around 2012, which really enabled 60 watts per cable. And so that was really at the point where PoE lighting became a reality, and you really had enough power there to power decent sized LED fixtures and grow from there. And then about 2 years ago, the IEEE ratified the new BT standard, which allowed for, you know, over 90 watts and really up to 100 watts per home run cable, per Ethernet cable. And so then, you know, that really, from our standpoint, from the Igor standpoint, that really gained a lot of traction for us. You know, that's, you know, higher power fixtures or more fixtures you can power from the same port and such. And so, you know, as the power has grown, then you're also looking at, you know, making sure that the cable that's used to transmit that power is appropriate for that power level. So you're getting into your, you know, either if it's a Cat5e, then usually it's a PoE specific Cat5e cable that's got thicker copper in it, or a Cat6 or a Cat6a to be able to transmit that power, that DC power efficiently. And of course, with the last two columns there, it's 60 watts and 90 watts, you're using all 4 pairs, all 8 conductors to transfer the power over the cable. So we'll move on to the next slide. And so this, you know, when I talk about 2-pair versus 4-pair power, this kind of shows, you know, that power and how it's getting transmitted through, you know, those individual twisted pairs within that Ethernet cable. You know, it's on the left would be the PoE Plus standard, which was only 30 watts. On the right is really UPoE and the new BT standard, which is, you know, up to, you know, 90 plus watts, 100 watts, utilizing all 4 twisted pairs on there to transmit that power to the node at the end of that cable. All right, so now we'll look at what a traditional line voltage lighting control system would, you know, the components that would encompass that, you know. And so you've got room controllers, you've got power packs, conduit, junction boxes, kind of all these different parts and pieces, you know, that are both line voltage, and you've got some low voltage things in there. And so, you know, you really, you know, have a lot of parts and pieces to implement your traditional line voltage control system. So Amy, if we'll jump to the next slide, then we'll compare that to a typical PoE installation on the right side, where you've got that power and data integrated into that same cable. And then you also have that additional functionality built into the Igor nodes, so it's not just the LED drivers in the Igor node. You're picking up sensors, you're picking up wall controls, etc. You don't need any conduit. That cable can all be pulled, through the cable tray, by low voltage contractors, so you don't need the higher labor rate of some line voltage master electricians and such. So really a lot fewer parts and pieces, a much more simplified bill of materials with the PoE installation and such. So with that, let's pause. Are there any questions anybody would like to ask before we move on? Doesn't look like anybody submitted anything through the chat. So, okay, that's fine. If anything, comes to mind, feel free to submit questions through the chat, and we'll keep on rolling on. Here's kind of another, deeper dive into what some of the connections look like in an Igor PoE system and such. So in this case, we've got a couple of light fixtures connected to an Igor node. We've got an occupancy sensor, we've got a wall switch, all connected to that same device. And so, as I mentioned on the previous slide, that really reduces your bill of materials. We have a lot of functionality and compatibility built into the Igor nodes. So it looks like maybe we had a question come up.
Yeah, and we got a question from John saying, how is emergency lighting handled in PoE?
Sure, that's a great question. Great question. Yep. And so at Igor, we do have UL 924 listed versions of our nodes that handle emergency lights. Typically, we, from a emergency power source, that'd be compatible with, say, a generator, on-site generator, UPS or inverter that would power just those PoE switches that are serving emergency lights. So we typically want to split those off, and so we have PoE switches and nodes that power normal lighting, and then we have separate PoE switches and nodes dedicated to the emergency lights, and thus those are on the emergency power circuits and such. And we've built into our software and our node programming that we have a heartbeat that goes out to each of our emergency lighting nodes. And if utility power to the building is lost, and thus any path in that heartbeat is severed or dropped, network or server wise, that heartbeat drops. And so our emergency nodes within 5 seconds will turn on their connected emergency lights at 100% or whatever the emergency dimming level is. So, emergency lighting has really been a hot topic for us lately, about the last year or two. Working with different municipalities on what their AHJs will approve for emergency lighting via PoE. And a lot of what I've seen with the growth of PoE over the last 6 years is adoption and education and such, because it's a new technology. People aren't always familiar with it. So a lot of times it's blazing a new road to get the technology accepted. So it looks like maybe we had another question submitted. Or
yeah, so we have one from Joe asking, would the EM transfer you spoke be of UL 924 approved?
Yeah, yep, certainly. And we've already gotten our UL 924 certification on that solution setup, and the UL is an advocate of ours for this. So the UL will speak with your local building department, your local AHJ about the UL solution on our emergency lighting solution, and how it's approved and how it meets NFPA requirements and such.
Awesome. And then we do have one more here asking, are the AV integrations, backnet, or load shedding features available?
Yeah, certainly. That's a great question. Yeah, we do have some partners that do a large number of AV integrations, and you know, that's really kind of their specialty, and so they've integrated our Igor solution, PoE lighting solution, into a lot of conference rooms and AV setups that they do for those conference rooms and such. You know, so one example is that we have an integration to Crestron that will allow Crestrons to send secure commands to our Igor lighting system via our API. And so here in a couple slides, I'll show you where that API interface is located and touch lightly on it. You also asked about backnet. We have a backnet over IP add-on module that will allow for incoming commands to the lighting control system via backnet over IP. And then we recently expanded that capability to send outgoing commands via backnet over IP, primarily targeted at other lighting control systems that are backnet enabled. But we're hoping to expand that to also HVAC communication via backnet over IP in the near future. And then from load shedding, yes, we have a load shedding feature built into that backnet plugin to allow you to configure X amount of lights to be dimmed to load or to shed so many kilowatts of lighting energy. So yeah, those are that's a really good question, and those are things that we have covered and have added recently with our solution.
That is fantastic information. There is a follow-up question on that. Are there nodes that have dry contact closure outputs for control of items like shades from a PoE switch?
Oh, sure. Yep. And so we don't have a dry contact built into the nodes. Typically, we would utilize an external relay with, say, a 24-volt DC coil. We do have relay control outputs, but they're really designed for just a small amperage, just enough to run that relay coil. But that, for certain instances like plug load control, or if we're controlling, say, line voltage, motorized shades, etc., we would do relay control via some external relays, such as like a functional devices relay in a box. We've used a number of times for that application.
Fantastic. Those have been some really good questions. So continue to use that Q&A chat box, and we'll bring them up as they go along. But Andrew, I'll take it to your next slide.
Great. Okay, so we've kind of covered some of the basics of PoE, and I've kind of put out some teasers about the Igor solution and such. And so this is really the Igor technology stack from top to bottom. So we've got our cloud portal offering at the top, which is really a data acquisition and analytics platform at the top. The next level down, we have our Igor Gateway, which is our on-premise server software. So that's the main brains of the control system on site. And so to the right of that, you see that the API I mentioned before, as well as that backnet add-on module. And so we've really designed our system with integration to other systems in mind. And so the API is a secure API, but also a very robust API in that it has got a ton of different methods and interaction points to control lighting and such. And essentially our whole user interface is built on top of our API. So there's no backdoors or any secrets, secret control and access we keep to ourselves. It's all exposed through our API in a secure fashion. Moving on down to the next level is that power sourcing equipment, the PSE level. That's really your PoE switches. That's really kind of your network layer. Then we get into the Igor nodes, and then the low voltage devices at the bottom. So looks like maybe we had another question come up.
Yeah, does the Igor Cloud Portal or the Gateway Support JSON calls. And I don't know if they refer to that as JSON calls.
Yeah, yep. JSON, yep. That's a term that our software developers use quite a bit, and a lot of the formatting of our data and such is in JSON format. And so I'm trying to remember on the API at both the gateway and something I didn't show on here is we're developing out an API at that cloud portal level, and I believe that the data returned from those API calls is in JSON format. I don't do too much programming, but I know we do use JSON a lot, and that's kind of our preferred format from our software team. So with that, I think we've got a couple of transitions on this slide, kind of highlighting the Igor Cloud Portal. Oh, looks like we had another question come in. Okay, case studies available that highlight the cost savings of PoE that were touched on. Certainly, yep. We've got a number of case studies that we can make available through this. Yep, we've got some PDF files on those case studies that we can get sent out afterwards, certainly. So I kind of went through the stack. We're going to show one slide on the cloud portal here. This is just a screenshot showing our energy monitoring screen. We have energy monitoring built into all of the Igor nodes. And so on a minutely basis, that data, that lighting energy consumption gets collected by the on-premise gateway server, and it gets uploaded to the cloud portal, and it's available for analysis and export from here. So this is a pretty nice screen to demo to customers and such. You can do a lot of slicing and dicing there. So, so moving on, we've got our Igor gateway level next. As I mentioned, that's the on-premise server software that you use for commissioning and control and maintenance of the system. So we'll jump to a quick screenshot of that. It's got a browser-based interface, so you can really access this UI from anywhere within the building that say your building maintenance person or IT people have network access back to this, and so this UI is used for all of the configuration, local reporting, and any troubleshooting of the system. So moving on to the next slide, this is really that PSE layer, that network layer, and so this can be comprised of both the PoE power sourcing equipment, as well as just your normal data switches at the core. And such. And so really we have designed our system to be compatible with many different manufacturers, network switches and mid-spans. I've got a number listed there as far as Cisco, Dell, Microsemi, Ruckus, Transition Networks, Versatech. I've got a whole stack of them in my office that companies have sent me for compatibility testing and such. And we also have a document listing those that have been tested. So, all right, so moving on down to the Igor node layer. And so on the next slide, we'll show a couple different pictures of our Igor nodes. We're on our 7th generation of nodes now, and so with each generation we've of course learned and improved and expanded their capabilities. And so these 3 from top to bottom are our 5th, 6th, and 7th generations. And they've been compatible. The first top one, the Rev 5, is that 60 watts design, whereas the bottom 2 are designed for 99 watts. And you can see how the middle one there has the red label on it, and so that indicates that it is a emergency lighting UL 924 listed node. And one quick thing I want to mention about the UL listings we've got on our nodes, we've designed them to be as flexible as possible as far as installation goes. So we've got our UL 2108 low voltage lighting listing on them. UL 2043, the third one down there, is the plenum rating. And so that means these nodes can really be mounted virtually anywhere, whether it's in the fixture, on top of the fixture, remotely. I've even seen nodes mounted on the wall in an IT closet, etc. You can really mount them anywhere. And then of course we got the UL 924 emergency lighting listing as well. So lots of flexibility and capabilities there. So we'll jump on to the next one. One other thing that's unique to our product line and I really want to highlight is our daisy chain capability. And so that really allows us to optimize and to use every watt available from that PoE power source. And so, we can daisy chain up to 5 nodes together. And that really means, we can control multiple lights independently off of that same PoE home run cable. So it adds a lot of flexibility and capability to our system. So if we've got 90 watts or 100 watts available back in that data closet, then we can put 1, 2, 3, maybe even 4 or 5 fixtures on that same home run sometimes, and really use every single watt available, which allows us to reduce the number of PoE ports required and thus reduce the number of PoE switches, which saves on rack space, that saves on overall project costs, etc. So with that, we'll move on. And so really the last section is really the low voltage devices. And so these are really the devices the occupants of the building are actually going to see, whether it's your LED fixtures, your LED tape light, your motion sensors, ambient light sensors, temperature sensors, etc. We're always adding to this list, and motorized shades on here as well. So so now I've got some pictures of an installation that was completed about a year ago. This is a pretty unique installation in upstate New York, up in Rome, New York. This was a highly integrated project where all of the interior lighting was PoE lighting. We also had PoE powered and controlled motorized shades by Somfy in this one. This is one of the largest Somfy PoE installations in the US or in the world at the time. And then we also have Bluetooth beacons, which allowed for real-time location sensing throughout this office space. So as we go through some of these pictures, all of the lighting that you see is PoE powered. I think we've got, here we show one of those motorized shades about halfway down. And so that's all powered and controlled through the Igor PoE system. And so here we've got the next few slides, we've got some examples of what those PoE data racks can look like. And so in this case, this rack is showing the emergency lighting with the red cabling going out to Igor emergency nodes and emergency lights. And then the green cabling is going out to those motorized shades, the PoE powered motorized shades. And so if we go on to the next slide, all of the gray cabling was for the PoE lighting. So that's all of those ports and home runs are going out throughout the office to that. And so, I wanted to highlight, these slides because this is what a nice, well-combed, well-installed installation can look like. And then in this case, the blue cabling is just your data cabling, just your Ethernet port data cabling. And so, the installation contractor did a really nice job of dividing up, what was being served via cable coloring, via the racks and such. So this is one of the nicer installations that I've personally seen. And then finally, we kind of have a quick shot of, that Igor gateway server there on the bottom, the Dell 2 rack unit server there. So this is really what a quality PoE lighting and Igor installation can look like. So it looks like we had a question come up.
Yeah, we have a question from John asking, have you ever had a client IT department dictate cable colors?
Sure, yeah, absolutely. And really, the client, is really in control, and so they can specify that. And, if they don't have a preference, we can make recommendations. Usually, since one of our company logo colors is yellow, usually we like to use yellow cabling for PoE, but, it can really be anything. We haven't found a real hard defined standard for the cable coloring, but, this project here was a good example of how it can be used to easily identify those devices and their purpose.